Okay, so 5-3 using the quadratic formula. Let's analyze the structure of quadratic formulas and examine common student mistakes. So consider Javier's work. He's determined the exact zeros for this formula, x squared minus 14x plus 19. So here's Javier's work. He's identified as A, B, and C, and he's done the workout. And you're going to identify the error he made. So write down here what error you determined he made. So check all his steps and find his mistake. And then you're going to solve using the quadratic formula correctly and get the correct answer. Okay. And when it says leave the solutions in exact form means not to estimate any radical values or round decimals. So if you're asked to leave this solution in exact form, then you're going to simplify your radical. So we've been using, a lot of you went to decimals on the last exercises. We're now going to simplify the radical instead of going to decimal. So I'm going to do A and then you'll do B. So for A, identify A equals -2, B equals -3, and C equals 7. So negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So -3 is 3 plus or minus the square, -3 squared is 9. -4 times -2 is +8 times 7 is 56. And then 2 times -2 is -4. And if we continue that, we have 3 plus or minus the square root of 65 over -4. Right? And so we would try to see if we could simplify 65. So if 65 is 5 times 13, both of which are primes. So 65 does not simplify. So the only thing in our final answer, we don't like to leave negatives in our denominator. So we're going to change the sign on every term. So the 3 becomes -3. The plus and minus would change signs, but we'd still have 1 plus and 1 minus. The 65 and the 4 become positive. That's the answer. You can split it apart and write -3 plus root 65 and -3 minus root 65 over 4. That's up to you if you want to split it apart or just leave your final answer like this, which indicates both answers. Okay, so that's the exact form, and because it has a radical left behind, it is irrational. It asks you to identify as rational or irrational. So you're going to now do 2B. Okay. So now we have Lauren solving a quadratic equation. And here's her work. So again, check her work, find her error. She made a mistake. And then it says correctly solve and classify it as rational or irrational. So you're going to find her error in her work, and then you're going to correct her error. All right. After you do that, it says use technology to graph each side of the original quadratic equation. So you're going to graph in Desmos or on your graphing calculator, y equals x squared minus 7x minus 8, and separately y equals 3. Okay, so you're going to graph that, sketch the graph you get here, and then interpret the meaning of where those two graphs intersect. There'll be 2 intersection points. Okay, so you're going to figure out where they intersect once you graph them. Again, you can use your graphing calculator or Desmos. Either one will work. Again, you're graphing these 2 equations and figure out where they intersect and drawing a sketch here. For D, it says next rewrite the equation so that one side of the equation is equal to 0. So we're taking the same equation, which was x squared minus 7x minus 8 equals 3. And we're going to solve equal to 0. So I'm going to minus 3. X squared minus 7x minus 11 equals 0. And then it says use technology to graph each side. So now we're going to graph y equals x squared minus 7x minus 11. And separately y equals 0. Graph those on here using, again, Desmos or your graphing calculator. And then you're going to interpret the intersection points once again. Okay. And then for E, it says compare the values you got from part C with part D and the solutions you got for the quadratic formula, which was in part B. So you're comparing what you got for part C, part D, and part B, and saying what you notice. And then in number 4, use the quadratic formula to determine the zeros for each function, round solutions to the nearest hundredth, and say whether they're rational or irrational. So for this one, I'm again going to do A, and then you can do B. So for A, we're going to set this equal to 0. So A equals 2, B equals 10, and C equals negative 1.02. So we're going to do negative 10 plus minus the square root of 10 squared minus 4 times 2 times negative 1.02 all over 2 times 2. And if I simplify negative 10 plus or minus, 10 squared is 100, and negative 4 times 2 is negative 8 times negative 1.02 is positive 8.16, and that's being divided by 4. And if I simplify, I get negative 10 plus or minus the square root of 108.16 over 4. If I split that apart, it's negative 10 plus the square root of 108.16 is 10.4. Actually, it says the nearest hundredth. So let me just check that because I rounded wrong. So the square root of 108.16 is, exactly 10.4. So 10.4 divided by 4. And then we got negative 10 minus 10.4 divided by 4. And the answers are negative 0.1 and negative 5.1. So now you're going to do the same process on B. Right? And it says, are they irrational or rational? Because it's a decimal that ends, it is a rational answer. So decimals that end or repeat are rational. Decimals that go on forever are irrational. So this is reflect on the different quadratic functions you have solved so far in this lesson. So looking back through the lesson, how many zeros does each function have? So you're going to count how many zeros they have and write your answer here. Do all quadratic functions have 2 zeros? So see if you can think of any in which there's not 2 zeros and explain why or why not. Do you think that a quadratic function could have no zeros? Is this possible? Explain why or why not. And then could a quadratic function have more than 2 zeros and explain why or why not? So you're going to think through that and answer those questions. And then tomorrow's lesson will build off of these ideas. If you need any help with any of this, I will be available from 10 to 11, so make sure you stop by and ask questions or email me.